Well, hi there everyone. This is Chris Fregley from Amazon Web Services. I'm a developer advocate that focuses on AI and machine learning. And today we'll be talking about preparing your datasets at scale using Apache Spark and SageMaker Data Wrangler. The problem that we're trying to solve is that pandas and scikit-learn, which are very common Python libraries for data exploration, for machine learning, classic machine learning, these libraries do not scale beyond a single instance or beyond just your laptop, for example. And so when dealing with larger data sets, which we will be doing today, we need something a little bit more full-featured, more distributed, and that has this cluster scale built in. And so Pandas, this is an open source library for data ingestion, sort of notebook-based analysis, ad hoc analysis. We can do some light transformations with Pandas, but just keep in mind that you can only operate within one single node. So if you do need to scale out, that's difficult to do with Pandas. Now, scikit-learn, this is a classic machine learning framework that can do feature engineering, can do model training, can evaluate and then compare models. The problem is, once again, we can only operate on a single node in our cluster. So this is where Spark comes in. So with Apache Spark and SageMaker, SageMaker fully supports Apache Spark. We can do serverless Spark with SageMaker. And Spark actually pops up in quite a few different areas inside of SageMaker, which I will highlight here in a bit through a series of demos. So Spark really is meant for distributed data processing. So from the beginning, Spark was designed to operate on clusters and large data sets. And which is why Spark has become very popular. Spark also supports Spark ML, which is a set of machine learning libraries that you can use on top of Spark. We will get to that in the final demo where we will actually train a recommender model with Spark and SageMaker. SageMaker is a managed service, of course, to run either data processing jobs, to train models, to tune models. You can deploy models, you could check for bias, you could check for drift, yes, all sorts of stuff. We have demos for this all here in a bit. With SageMaker, you pay just for the resources that you use. You don't have to manage your own clusters. You can spin them up and then tear them down, auto scale them out. You could use spot instances to save money. So we will use SageMaker throughout the rest of this session. So this is the first demo here. Now, what we're going to do is actually check our data quality. So we have a data set that's called the Amazon Customer Reviews data set. This is about 150 million customer reviews for products from the years 1995 till 2015. And we will use this open source library called DQ that was created by AWS that will create a Spark cluster beneath the covers. So this is a nice Python library, nice easy to use DSL, domain specific language Python library that works with SageMaker and can spin up Spark jobs. So let's actually see how this works. All right, so here I'll post the link to all of this GitHub. This is all live and you can download for yourself. So this is our data quality. This is where we will actually be taking the customer reviews data set. We're going to use something called DQ here. And DQ, this is an open source library. Here's a blog post that describes it. I'll have links to this later as well. And what's happening here is DQ spawns a Spark job for us. And yeah, I'll show you here in a bit where we will actually define constraints and say what we are looking for in our data. And if some constraint is not met, for example, with this reviews data set, there's something called star rating, which is the rating that the user gave the product when they submitted the review. If all of a sudden star rating comes in negative or 0 or something outside of the bounds 1 through 5, then we probably want to halt our our pipeline and find out what is going on. Okay. Also, DQ so with DQ we can actually suggest new constraints also. So once DQ sees all of our data, we can now actually suggest all the constraints. So we are going to focus on product categories, star rating. We've got the review body also. And at some point, and not in this demo, but we will be training a model, actually using BERT, which I have links to all of this later as well too. We will train a BERT model to predict star rating from the review body. But before we want to do that or create those features, those BERT features, we first want to check our data quality. If the review body, for example, comes in empty, we certainly don't want to start a training job. There is likely something upstream with the actual application that's submitting these empty reviews. All right, here's just a little bit of boilerplate. This is the actual PySpark code. So this is PySpark, but we're using DQ as just a regular old Python library. And so we could specify our CSVs. We could also use Parquet for this as well too. The Amazon customer reviews dataset does come with, it has been curated and has Parquet and CSVs as well. And so here's where we're actually structuring and telling Spark what our CSV contains. We can then make reference to these fields later on when we create the analyzer below. And we can add analyzers for things like completeness. If something is complete, it means there are no nulls in this data. We can do an approximate count distinct. We can do mean average star rating. We can look for correlations between fields like total votes and star rating, total votes and helpful votes. And so these are all fields, and this is all specific, of course, to your domain. Here's where we're specifying minimum, maximum for the star rating. There's also this field called marketplace. This particular data set had 5 marketplaces, so we are telling DQ that all of our reviews must come from these 5 marketplaces. If they don't, then there is something wrong that we don't understand. And so therefore we should halt the pipeline. So we will then output all of the data. This is just, typical PySpark code. We're going to write out the CSV, and then we will ultimately view this CSV in our notebook. All right, and I mentioned we were going to use SageMaker, and specifically SageMaker processing jobs. So SageMaker does support Spark natively through something called PySpark Processor. I am using 2.4 for this. I didn't need anything newer. 2.4 Spark was totally fine. I can give it the instance type here. I'm just using one instance type just for cost savings. You could jack this up to 10, to 20, and depending on your budget and the wall time. If you wanted to complete this faster, you would increase the instance count, but just keep in mind that will incur some extra cost. All right, scrolling down a bit here, this is where we're actually running the PySpark job on SageMaker. And so here I've specified the DQ jar. I could also specify Maven coordinates. In some cases, I like to actually download the jar locally and not depend on third-party services. That way, if Maven, for whatever reason, is down or something, I can still process my data. All right, so we can look at the processing job, the output data, or we could just look at it directly here in our notebook. So I've generated a CSV out of this processing job, and now I could actually see if my constraints succeeded or failed. And so I can add this to my pipeline. And if something fails, I could halt my pipeline. Or if suddenly correlations start to occur that were not there, or if the mean star rating started to dip below 2.0, that might be cause for some alarm, and either look into what's going on from the application team or try to fix this data somehow. And so possibly you would want to retrain based on these type of like statistics here. Okay, so total votes and star rating has almost no correlation. Total votes, helpful votes has high correlation. Here we see the marketplace. So these and so I would run this continuously on new data as new data is coming in, right? Okay, total votes and then helpful votes too. When someone leaves a review, the community can then upvote or downvote that review. So there's total votes and then there's the thumbs up helpful votes. The difference between total and helpful is the non-helpful, of course, so there's no need to maintain a separate field for that. Right. So I think we're good there. Let me pause that. Go back to the Okay, our next demo, we're going to actually transform raw features, so raw data. So for example, we can convert, if we have star rating 1 through 5, we can convert star rating 1 through 5 into, let's say, negative, neutral, and positive sentiment. So maybe we don't need to predict all 5 classes from the actual review text, but we can just do sentiment analysis simple with 3 different classes. We will also detect bias. We will look at feature importance, and features we will tell Data Wrangler, SageMaker Data Wrangler, what field we are trying to predict, which for us is star rating. And then Data Wrangler runs a report. It's actually running Spark behind the scenes, and it is then telling us which features are the most important. So let's take a look at this. Let me start this demo here. Oop. All right, this is our flow. So here we'll actually be doing transformations. Here's our data set, the original data set. Data Wrangler is what we are using. This is all part of SageMaker Studio. This is all built in. And this is our data set on the left with all the data. On the right, we've actually done 4 transformations here. There are 300 plus transformations, and you can provide your own PySpark code that can operate on these data sets natively. And these all become part of the flow. So here's our 4 steps. First step is to ingest the data. Here we're using Athena, which we have previously registered our data in S3 with Glue. Glue is a Hive Metastore compatible. Here is the Glue screen here. So Glue is pointing to our Parquet data. So now we've switched over to use Parquet. It's the same data set, just in different format. And Glue now knows about the schema of our data. So here we have review date, we have year, product category, we have star rating, we have the review body as well. So after we do the ingest, we specify query string here that'll pull in data. We could filter as appropriate. Here we want to look at all of the data. The second step, Data Wrangler actually inferred the types. We can change the types. For example, star rating is only 1 through 5. Maybe we don't need a long. It could just be integer or something like that. And the third is, this is where we are going to start transforming our star rating, which is 5 classes, 1, 2, 3, 4, 5. Instead of possibly predicting all 5, maybe it's good enough for our use case to just predict if it's negative, neutral, or positive sentiment. And so we can use min-max scaling, and this is actually triggering a Spark function on the back end without us having to write any code. And this will then create a new field called star rating min-max scale built in, and that will be between -1 and 1. Okay, so there's our min-max scaler. Now, we can also specify a custom PySpark function. That custom PySpark function, which we'll do next here, can actually operate on the feature that was just created in the previous step. And so I'm going to show you the actual code that was used here. So this is the actual code. This is just straight PySpark code. I'm saying use that previously processed, so I scaled 1 through 5 between -1 and 1. And so some of those came out to be 0.5, some of them came out to be -0.5 because there were previously 5. Now I'm going to use the floor like PySpark function. And yes, I can also specify Spark SQL too, which is really cool. But here I was sticking with Python because we're using it everywhere. That little box is actually bigger when you enter the code. Here it's just showing the code, which is why I showed through like text edit here. So you'll see star rating min max, which was created in the step 3, still has 0.5 and then -0.5. Yes, I want to floor those, which is going to drop those. So 0.5, -0.5. Yeah, so now we are left with sentiment between, which is 3 values, -1, which can be interpreted as a negative sentiment, and then neutral for 0, and then 1 is positive sentiment. Let's shift gears a little bit and talk about bias. So during our modeling and our feature engineering phase, we want to actually take a look at bias. And so here I've pre-created 2 of these analyses. So one of them is bias, and we'll see bias report. The second one is feature importance. And this is going to, and so both of these run Spark jobs behind the scenes, right? And so bias report is taking a look. I tell it I want to predict star rating. And what I'm doing here is I'm going to analyze this data set, but I want to focus on the predicted values 5 and 4. And I want to do that with a facet of product category. So the term facet is really just a column that I'm specifically trying to analyze. And yes, actually, I'm going to change this to be sentiment, sorry, I could change this to sentiment and use 1, -1. I think in this demo, I was sticking with the previous 5 and 4 for the star rating. But here, the key here is I specifically want to see how does product category, or is this data biased to predict 4 or 5, depending on which product category. And so here I could specify different metrics to actually measure. So there's things like class imbalance, there's LP norm, KL divergence, KS distance. And so a lot of us have different preferences. And then on the left here, I can actually analyze all of these metrics and see where there is bias or class imbalance. I also have links to different white papers. I can then drop down and see some hints as to when I should be using certain metrics versus others. And yeah, let's see. All right, let's switch gears here a bit and go to feature importance. So this is actually running a Spark job beneath the scenes. This is called Quick Model and part of SageMaker Data Wrangler. And I am pointing all of my features and I am asking, yes, I asked Data Wrangler to tell me what are the most predictive or most important features towards predicting the star rating from this data set. And so it's still considering some of the ones that I had generated in previous steps. So of course, star rating, min-max scaled, which was based on star rating. Of course, that's going to be predictive. So I would actually drop that one. But like more importantly, we see review body, we see total votes, we see product title, we see the review headline, helpful votes, and then product category just a little bit, year just a little bit. And so this is telling me where I should be focusing my attention when I am doing my the next phase of this pipeline, which is feature engineering to prepare for model training. Okay. Also, I can export. So this is one of my favorite features. I can export what I just built visually as a Data Wrangler job that I can run over and over. I can generate pipeline code for SageMaker pipelines. So this is doing code generation, and this actually generates Jupyter notebooks. This generates Python code. This will actually generate code to put these features into the new SageMaker feature store, which was released at reInvent 2020. And I think I'll show some examples here too of the generated code. So that one, that first one is a Data Wrangler job. The second one was SageMaker pipelines. That third one is Python code. And fourth one is feature store. So I could actually run these notebooks over and over, or I could schedule them as jobs and build this into my pipeline. Okay, here's the final demo. This is one of my favorite because we're actually training a model and generating recommendations. We're using Spark with SageMaker processing jobs. Now, some of you might ask, why aren't we using training jobs to train a model? And we certainly could, but here I was highlighting this sort of lightweight processing job feature of SageMaker and specifically the Apache Spark support. And by using processing jobs, we're still gaining the high-speed access to S3 and all of the like SageMaker optimizations, pay-as-you-go, and all the integration with like CloudWatch metrics, CloudWatch logs. So really, processing jobs are very generic, and I wanted to highlight this as a way to use processing jobs to actually train a model. And in some cases, you might even consider training a model as training a transformer. And once this Spark model has been trained to generate recommendations, I can now transform raw reviews, and I think we're going to use movie reviews for this case from the movie lens data set. I can take user item and then that review 1 through 5, and I can create now recommendations. So I'm basically transforming raw data into real live recommendations that can then be pulled into some sort of operational data store like Cassandra, like DynamoDB, and then when users log in, I could serve up those recommendations. So let's see how this works. Let's get to the top here. So there's just some SageMaker boilerplate code that we always use everywhere. We're pointing to where the movie lens data set is. Now, movie lens data set has 3 fields, has user ID, has movie ID, and then the actual rating. And ratings, I believe, are 1 through 5. So here we have about 32,000 ratings. This is probably small enough where we could actually just do it with pandas or with scikit-learn, but with a much larger data set, which movie lens does have much larger versions, we would then scale it out using Spark. Now here we actually are going to use Spark. We're just going to use one instance again for cost savings, starting small. If we need more, then we can add more. So here's the actual PySpark code. Now there's no DQ, there's no other libraries here except PySpark. And I'm splitting the data. I'm using ALS, which is alternating least squared, which is a form of matrix factorization and collaborative filtering. I'm passing that data through. I'm sending it to my Spark nodes, which can be 10. I can have 100 nodes. I can have 1,000 nodes. Here we're using one single node. We're choosing the R5 instance type, which has high memory. And we're going to let Spark do its thing. So here I just specify the location to the PySpark code. I tell it where the input data is on S3. I tell SageMaker processing job where to actually write the output, which is going to be my recommendations. And when all of that runs, we can actually take a look at the data. So here's our so I actually did this two different ways. I generated all recommendations, which can be hundreds and like hundreds. Oh, and so yeah, so this is movie to rating. So this is a basically, yeah. So let's focus on the top 10, a little bit easier to explain. So for a specific user, I now am showing what are all of the movies so that when this user logs in, so this data would get loaded into some operational data store, which then would serve up those recommendations when the user logs in. All right, let's go back to here's the summary. Pandas and scikit-learn do not scale to large data sets. If you are using large data sets, you must shift to something like Apache Spark. We recommend that you run Spark on SageMaker. You pay for just what you need. You have super optimized access to your like different data stores like S3, like Redshift, and we had demonstrated then three like different use cases for using Spark with SageMaker at scale. So the first one was using SageMaker processing jobs and this open source library called DQ, which by the way is short or is a full spelled out version of DQ, the two letters, which is short for data quality. We used that library with Spark processing jobs to actually analyze our data set and tell us if there were any problems or things that we were not expecting. We were also able to generate suggestions after like DQ has seen all of our data. Then like DQ can actually suggest that we start looking for different constraints, more constraints based on the specific values that were in each column. Yeah, so that's really useful. Things that maybe as a human we didn't think about, but DQ recognized different patterns in our data set, different correlations that maybe we didn't know about. And from that point on, we can actually start to check for those new constraints. Second demo, we actually transformed the raw customer reviews data set by Amazon, 150 million reviews from the years 1995 till 2015. We detected bias relative to product category, saw that there was a little bit of class imbalance, and specifically relative to predicting 5 and 4 for the star rating. We then looked at the importance of features that helps us then select features for our model, for training our models. All of that was being done by SageMaker Data Wrangler with just a few clicks and small snippets of PySpark code. And the final demo was we used SageMaker processing jobs again to run Spark to actually train a Spark ML model and then generate recommendations for us. So pretty exciting stuff. Thank you so much. There's a new book that's coming out. It's actually 2021. So hopefully soon. And me and my co-author Ansha Barth and co-worker as well We spent the last year writing this book. This is the outline. We cover a lot of grounds. It's 12 chapters. We have 500 pages and hundreds of samples that certainly dive like way deeper than we were capable of in this 30 minutes. Thank you so much, and hope to see you soon.